Hi, my name is Harrison King, and today I'm going to be talking to you about the implementation of unmanned aerial systems or drones in the supply chain. The purpose of this senior thesis was to research how unmanned aerial systems can increase productivity and reduce waste if implemented into the automotive supply chain. The disciplines used for this project were industrial engineering and organizational leadership. An interdisciplinary approach is almost necessary for this type of project just because there's so many factors and so many variables that have to be taken into account when researching the implementation of UASs. Repco states that complexity means that the problem has multiple components studied by different disciplines, which is true for this project just because there are so many different things, like I said, that have to be considered when implementing the drones. You have to think of the worker, of the environment, of the building, of the uh, engineer operating it. You have to think of everything that is going to be involved when you are implementing these things into a workplace. The most relevant the relevant disciplines for this study that were considered were business, mathematics, engineering, supply chain management, project management, human resources, and organizational leadership. Excuse me. Obviously, there are many more that could be considered and will be considered when you are implementing them into other type of environments or other type of workplaces. But for this research project, the most relevant disciplines chosen to be studied and identified were industrial engineering and organizational leadership. Like I said, the disciplines chosen and used were industrial engineering, organizational leadership. Industrial engineering was chosen because it deals a lot with optimization, evaluation, logistics, and efficiency. All of these things are what will be the reason that you are implementing drones into the workplace. Obviously, you want to implement them so that work can be performed faster and quicker. It can be performed without as much waste and without as much strain and stress on the worker or the other machines used. Organizational leadership was chosen just because of the communication aspect involved with it. You have to be able to communicate the ideas from industrial engineering and from other disciplines with organizational leadership to make sure that the ideas are implemented correctly and efficiently. Some of the main components of industrial engineering are process improvement, eliminating waste, and inventory management. All of these things focus on um, efficiency and logistics and things that are used to make the process easier on a worker or easier on a supply chain as a whole. Now, in relation to drones and unmanned aerial systems, I think the main components of industrial engineering that will be used will be inventory management, supply chain overview, and identifying bottlenecks. Um, Inventory management, a drone can be sent out into a warehouse, into a uh, building, and just take inventory as it's flying through via camera, and not make that allows the worker to be stationary while that drone flies around and takes inventory. Uh, thus eliminating the need for the worker to physically walk through a warehouse or drive through a warehouse. This puts all the work on the drone, which is really what is going to be, that's going to be the main reason why drones are being implemented, solely because just to make the life easier of the worker. Now, on to supply chain and identifying bottlenecks. I think drones can be used to fly overhead and identify any bottlenecks that are being created in an assembly process with that by taking times and takt times just to see how fast the process is moving and uh, how it could be moving quicker. The engineer can then look at these times and look at the feed of the video and look at all these things and determine that there is a bottleneck happening and that he can actually go out and make a change. And all this can be done while it's being stationary and the drone, again, out there doing the work and doing the thing necessary which the engineer would normally have to do. Another insight that is kind of mentioned in the research that I did was late adopters. Now, late adopters are someone who is resistant to change, resistant to the implementation of new technology, and therefore could delay the implementation of unmanned aerial systems and drones in the supply chain and in the workplace. You have to consider the training costs for these people to be trained on the new machines and new systems. If they refuse to kind of pick it up on their own, you have to hire someone to train them or train them yourself, and that takes time and that takes effort and that takes money. So that could be a problem when implementing the drones into the supply chain. Another thing that needs to be considered is at what stage should drones and UASs be implemented in order to increase development. You have to consider how if you implement them too early, then there will be the work will be solely relying on the drone, and that's not what you want. You want the drone to be a tool that the worker can use to make their life easier, and not have the drone doing all the work, but something just like a tool like anything else you would use in the workplace. Again, if you implement a drone too late, then some of the processes and things could have been going on for so long that the drone actually couldn't end up helping anything. You have to consider all these things when you are implementing drones. A conflict that I identified was a very simple one, but it was just the terminology used by the authors for quote-unquote drones. Boucher uses the term RPAS, or remotely piloted aviation system. Oliveras uses unmanned aerial vehicles, or UAV, which is probably one of the most common ones that we see in articles and other research. And then lastly, Raffaello uses the word drone itself. And obviously this is the most universal term along with UAVs, but if this could just be, if the terminology could be generalized to make it easier for research and easier for workers as well, I think that the term UAS, or unmanned aerial systems, should be used just solely because of that is what the FAA, the Federal Aviation Administration, that's what they use. So I think that should be generalized. Again, the technique to create common ground that I used was redefinition. Redefinition is defined as creating common vocabulary to facilitate communication between disciplines. Again, the term UAS should be generalized throughout all fields and all workplaces, just because it's the most universal term, and it would make it a lot easier when discussing future implementation. A comprehensive understanding was constructed because basically industrial engineers can't do this on their own, and obviously organizational leadership couldn't do this on their own. The ideas proposed by industrial engineers are communicated with organizational leadership. And obviously an engineer can communicate things with like data and numbers and reports, but obviously organizational leadership is just going to be needed to kind of connect with that worker, connect with the person that's going to be actually using the drone in the workplace. Obviously some of the applications which I've already discussed, but just again is inventory tracking or inventory management. You can deliver the tools and materials to workers. You can pick up a tool, a wrench, anything, a screwdriver, just take it to the worker, take it to them without having to go back to their workstation or work area, and if they're out in a field. And drones could also be used to perform time studies which is like I discussed earlier, the bottlenecks, identifying the bottlenecks by performing time studies that to see how long a process is taking. And then lastly, communicating the results. Unmanned aerial systems cannot be implemented without multiple disciplines because, I mean, it's a complex problem and when it comes down to it. It's going to be hard to implement them without multiple disciplines like industrial engineering and organizational leadership. So just because there's just too much to handle for one discipline, and there's many variables that have to be taken into account, not only with the technical side, but also with the implementation that is associated with the with UASs. And then some further research that I think should be considered that I didn't find much on are the economic effects associated with the drones, like how much money and how much time you're really saving by implementing the drones. Obviously, it looks really good on paper, but if it's actually implemented, how much are you actually saving? And then the training costs, I think, are another thing that kind of falls into that. The training for unmanned aerial systems must relate specifically to the fields of study, to specific fields of study. Like obviously, if it's a drone is being implemented in like a retail situation, it's going to be different than how a drone is implemented into a warehouse or supply chain. So there's my references. So that's all I have. Thank you for listening, and if you have any questions, just let me know. Thanks.